two.
Do any of you have questions for me about registration? Do you know what to do next hour? Like, well, I don't know. Anyone have questions?
I'm so sorry.
With you guys being in algebra 2, if you pass algebra 1, you pass geometry. If you pass this class, you just need a stats class. Sorry. You just need a stats class. Or all of you either signed up for elementary common stats or intro to stats. If you didn't take a stats class this year, it's okay. They suggest you do it as a junior, but you could do it next year. And then I would say if you haven't taken, like, if you're just feeling like I'm done with math, consumer math is a really good everyday math kind of class. So if you can fit that into your schedule, it's only 2 terms. Mr. Check teaches it, and it's very much like the math that you really would use in everyday life. So like taxes, banking, insurance, retirement, all that kind of stuff. I'm not sure of all the topics, but it would be something that would be a good class for you guys. If you're more like you've taken intro to stats and you've tested into some college classes, I would say that if you haven't taken intro to stats, take that. And if you want another college class that could potentially cover, like if you're getting a 4-year degree, college algebra is also a good one. Thank you. So that would be a good one that could possibly count for your college math class. But if you haven't taken the AccuPlace or you don't really want to do college classes, then what I would say is maybe try that consumer math. Okay. All right. And we have kids actually in the same year take college calc and consumer math, because college calc is our highest math class. Consumer math is probably one of our easiest math classes, but it's very good for you down the road. So, and it's two terms, so 1 trimester. All right, so today is going to seem like, what I don't like about today is it's hard to know that you got the right answer because everything is like decimals. And a lot of times it's nice to get a whole number and then you think, okay, I must have done that right. And today we want you to round things to 4 decimal places. Okay. So today what we're going to do is something called a common logarithm. And a common logarithm is just log of x. And I think I spoke about this earlier, but if you ever see log of x and there's no base, the common log, you assume it's base of 10 if it doesn't say otherwise. Okay. So the log key on your calculator, have we done that yet? You guys use the log key. The log key is to the left of the 7, and that log key is base 10. Okay. So, as I said, they have a log key, our calculators do. If you were to graph just log of x, this is what it would look like. Okay, this is your common log, what it would look like. And down here, this is super easy. All we have to do is use that log key on our calculator to the left of the 7 and hit 5. And for today, this is another thing that's different than what we usually do. I always tell you guys to round to 2 places. They want us to round to 4 places. The 10,000, good morning, is 4 decimal places. So here's what we're going to do. We're just going to use this log key right here. Oops. and hit 5. And then again, like I said, we have to round it to the 4th place. Now, if you guys look here, the 4th place is a 9, and there's a 7 after that. Now, if you guys put on the test 0.6989, I wouldn't mark that wrong. Rounding is not really what we're looking for here, but truly, you're rounding correctly. If I'm rounding to this place, do you guys know if that's a 7, that 9 would go up? And wouldn't 89 go up to 90? Do you guys get that? So it would really be 0.6990. But if you put 0.6989, I'm not going to mark that wrong on the test. So let's go back here. And it should be 0.6990. Okay. And then log of 0.3. So if we go log 0.3, you can get a negative. So don't think you're wrong today if you get a negative. So again, I rounded here to the 4th place, and there's a 7 after it. So this would become a 9. So negative 0.5229. Let's see. So negative 0.5229. So again, today we're dealing with what's called the common log, which is base 10, even though they don't always put that 10 in, it's really base 10. So really, you think of this as a 10 here in all of these, okay? And if you guys remember, you can do that log loop. So you could go 10 to the y power equals x. And that's what this is here. Here's the common log formula. And if I had to put it in exponential notation, it'd be 10 to the y power equals x. If I did this one, 10 to the 0 power equals 1. Now, this is something we might have talked about a few times, but anything to the 0 power is always 1. So you have to remember that. Here, 10 to the 1st power is 10, which anything to the 1st power is itself. And then this one, notice it's 10 to the m equals 10 to the m. So that's just taking those logarithmic equations and putting them in exponential. Okay. So now, last week or the week before, we learned how to solve exponential equations. And when we learned it, if you guys remember, we had that chart, which you still have a cheat sheet for, and we tried to get both of these to the same base, okay? And because we have that 3 there, can't 9 be written as 3 squared? Do you guys remember that? So 9 can be written as 3 squared, and then that's to the 2x minus 1 power. And then this is 3 to the 6x power, okay? So basically what we have there is 3 to the 2 times 2x minus 1 equals 3 to the 6x power. And last week we talked about the fact that if these are both to that same base, we can forget about these and say just that our exponents or our powers equal each other and solve it for x. So if we distributed, we get 4x minus 2 equals 6x. If I subtract 4x to bring it over, I get negative 2x equals negative 2. If I divide by negative 2, x is 1. Okay. So that's what we did last week when we were doing exponential equations, and we could get those to the same base. Today, what we're going to do is look at what happens if you can't get them to the same base. So if you ever had an exponential equation like this that you can't put to the same base, how you solve that is you take the log of both sides. Okay, so what we're going to do here is we go log of 4 to the x equals log of 19. Okay. And yesterday and the day before maybe, we talked about the power rule of logs, that if you have a power, you can bring it out front. Okay. And then we'd go x log of 4 equals log of 19. Okay. Then what I'm going to do is I have to solve for x. So what I would do then is try to get rid of this log of 4 by dividing by log of 4. And then these are gone. Okay. And when you type this into your calculator, okay, you're going to get a yucky decimal. All your answers today are going to be decimals. But what you have to do when you type this in is be careful. You either can put a parenthesis after this 19 before you divide by log of 4, or you could type in log of 19, enter, divide by log of 4. But if you didn't do that parenthesis or the enter, you would get every single one wrong. Okay, so you either have to go log of 19, enter, divided by log of 4. And I think I'm going to do it that way just because that's how I kind of usually show it. But if you wanted to do a parenthesis there, that's the same thing. So if we go to our calculator and go log 19, enter, divided by log of 4. Again, you're going to get yucky decimals, and you're going to round to that 4th place. Since there's a 6 after it, they want you to round that 9 up. So 39 would round to 40. So you'd get 2.1240. 2.1240. Okay. Now this next one, same thing. You can't write 5 and 106 to the same base. So then what you'd have to do is go log of 5 to the 3b equals log of 106. To solve that, you would want to take this power and put it out front. Okay, so you'd go 3b log of 5 equals log of 106. And I want to solve for b. I think what I'm going to do first is get rid of the log of 5. Let's do that. Let's divide by log of 5. And let's actually evaluate that and then worry about dividing by 3. Because otherwise it can be kind of a nightmare with parentheses. So let's go to our calculator and go log 106, enter, divided by log of 5. So log 106, enter, divided by log of 5. And let's say that, let's round it to the 4 places, 2.8976. And that's 3b. So now I have to divide by 3. And I would get that b is, if I go back to my calculator, I can just go divide by 3. And to the 4th place, it'd be 0.9659. And if you were off just a little bit, you know, say you got 0.9665 or something like that, that could be that you rounded too much here. I would keep these out to at least 4 places. All right, if we look at this one, again, 6 and 18, we can't write as the same base. Like 6 times 3 is 18, but we can't do 6 to a power and get it to 18. So what that means then is we have to go log of 6 to the x plus 2 equals log of 18. We're going to take that power again and bring it out front. And we're going to write that as x plus 2 in parentheses plus 2 times log of 6 equals log 18. Okay. Now, I'm going to try to get this by itself and just get rid of the logs for now. So let's do this. Let's divide by log of 6. Get rid of those. So these are gone. And then I have x plus 2 equals, and let's evaluate what this is. Let's go log of 18 enter divided by log of 6. So log of 18 enter divided by log of 6. And that is like 1.6131. So 1.6131. And when you notice here, what I have left there is x plus 2. So to solve that, I want to subtract 2. So all I have to do is go to my calculator and subtract 2 from what we just found. And again, today you can get negatives, so don't think you're wrong if you get that. So negative 0.3869. Negative 0.3869. And then this last one here. Again, 42 times 2 is 84, but I can't write 42 as a power or 84 as a power of 2 or 3. That would end up giving me those. So that's when you have to take the log of both sides. Okay, and then we're going to take this power out front, and we'd get x squared times log of 42 equals log of 84. And then what I always do is kind of leave that x for now, and I try to get rid of my logs right away. So I'm going to divide by log of 42. Okay, so what I would get then is x squared equals, and for this it's log of 84, and I could do enter divided by log of 42. So log of 84 enter divided by log 42 is 1.1854. 1.1854. And that is x squared. I want x. So what I'm going to do is take the square root of both sides. I ever showed you guys this or not? Did I ever show, like, if you want to take the square root of this on a graphing calculator, you can do your second x squared, and then you can pull that answer in there by going second negative down here. And what that will do is pull that number down. Have I shown you that before? Okay. And you would get 1.0888. Otherwise, you could have just gone square root and typed in, I would have typed in at least 4 decimals. So 1.1854. And you could do it that way too, and you get pretty close to the same answer. So this ends up being 1.0888. Okay, so now let's go here, and we're going to do exactly the same thing. The only difference in these questions is that it has a greater than or equal to sign. And what you have to remember when you do that is that if you're dividing by a negative, you switch your sign. Okay, that's the only difference. Otherwise, you just keep your sign. If you divide by a negative, flip it. So here, I am going to take the log of both sides. I'm going to bring that x up front. So it'd be x log of 3 is less than log of 15. And then I would just divide by log of 3. These would be gone. And I would just go to my calculator and type this in, make sure that I do enter here. So we can go log of 15, enter, divided by log of 3. And I got this 9 would go up because of the 7. So 49 would become 50. So it'd be 2.4650. So 2.465, and you could put that 0, you don't have to. Then if I go to B, we're going to do log of both sides. So I'm going to go log of 4 to the 5k is greater than or equal to log of 37. I bring that 5k out to the front. Okay, so I have 5k log of 4 is greater than or equal to log of 37. And again, the only time those signs matter is if you're dividing by a negative or multiplying by a negative, which we wouldn't do in this type. So we're going to divide by log of 4. I always leave the 5 and the k to the end. And then I would get 5k is greater than or equal to. Make sure we hit enter. So if I go log of 37, log of 37, enter, divided by log of 4. It's going to be 2.6047. 2.6047. And then we're going to divide by 5 to get k by itself. And when I do that, I end up getting 0.5209. Okay. And if I look at C again, I'm going to take the log. I'm going to take this y plus 4 and put it out front. So I get y plus 4, and I put that in parentheses, and I try to, thank you, try to get that by itself. And then what I'm going to do is try to get rid of this log of 8. So I'm going to divide by log of 8. Then make sure I hit enter here. And when I do that, I would get y plus 4 is greater than 1.3023. So don't get surprised if you never divide by a negative, because we don't think you will, to be honest. So really your sign is just like if you had it equals. Then we're going to subtract 4. And we'd get y is greater than negative 2.6977. And then this last one, if I take log of both sides, we get 30x to the second and log of 50. I bring that x squared out front. Then what I do, I always leave the x and I get rid of the log right away by dividing by it. So these are gone, and I get x squared is less than or equal to, and when you type in log of 50, enter, divided by log of 30, log of 50, enter, divided by log of 30, we get the 1.150, and that would be a 2. And that's x squared, so then I had to take the square root. When I do that again, if you like to save time and still get like the most accurate answer, you can go second square root. And to call that down, you can go second negative. And it's 1.0725. Right, then if we go to this last page, I think you'll find this is easier. It's a lot quicker, I think. But you're still gonna get decimals for this, and we're still gonna round to the 10,000, okay? We have used this change of base formula 2 other times this chapter. One of the ways we did it was when we had to graph log functions. If you had an older calculator, if you remember, we couldn't enter them the way that it's listed here. So what we did is we went, if there was anything in front, and then we would do log of the x. And if there was anything with that, we just kept it on top. Over, we divided by log of the base. Okay, and that's all we're gonna do here. So this first one's easy. You're gonna go log, and it's of this on top divided by log of 3 on the bottom. All you have to be careful of is doing that enter. That one's easy. If you go log 16, enter, divided by log of 3, we get 2.5237. 2.5237. Now this one looks harder because it has that to the 5th power. But what you would do there is, think about this, if I want to bring, yeah, I probably would bring that 5 here. I don't think you'd have to do that, but I probably would bring that 5 out front, and I'd write this as log 5 log base 8 of 4, okay? And then what you do on the top is you do everything except for the base. So you would write on the top would be 5 log of 4, and on the bottom would be log of your base. Now I believe that you could have, somebody wants to check this, I believe you could have left it the way it was and do this. And just when you type this in, go 4 up arrow 5, enter, divided by log of 8. So let's go to our calculator. If we do 5 log of 4, enter, divided by log of 8, that's what I get. If I left it as is and I went log of 4 up arrow 5, I would have to put a parenthesis. Okay, so that might be a little bit. So I'd have to go 5, and then I'd have to move my arrow. And then I don't think if I did the enter, then I'd divide by log of 8, and I would get the same answer. So let's see if we have to, if I went log 4 to the 5th, maybe I don't need a parenthesis. Yeah, I could do that and then go divided by log of 8. So actually you wouldn't have to bring that 5 in front, but you could. Okay, so it's 3.333 would be our answer. Or 3s, oops, as a decimal. Then this next one, again, has these roots, okay? And again, I think you could type this in two different ways, okay? The one way I kind of want to show it is because it'll help us with our next lesson, is that this really is log base 7. Okay, it's log base 7 of 5. And do you guys know that square root is really to the 1/2 power, and cubed root is really to the 1/3 power, and so on? So one way we could think of the square root is log base 7 of 5 to the 1/2. And then we could bring that 1/2 out front and go log of 7, 5. Okay, so how we could do that then, remember you do everything but the base on top. So if you don't like doing fractions, you could go 0.5 for the 1/2 log of 5 divided by log of your base on the bottom. Okay, I think you also could have done that with just going log, use your square root key and do 5 divided by log of 7. So let's check that and see if we get the same. So if I go 0.5 log of 5, enter, divided by log of 7, that is what I get. But I believe you also could have done that, whoops, as just log, then use our square root key of 5, enter, divided by log of 7. Did I erase that? Yes. So those two are the same. So either of those ways works. So if we go here, I get 0.4135. Okay, this last one has the cubed root. Okay, and there is a cubed root on our calculators, but you also could get the 4th root, and there isn't a 4th root. So what I'm going to show this as, you guys, is I'm going to do log, and that 39, I'm going to do 39 to the 1/3 power over log of 4. Now you could do that two different ways. You could put your 1/3 in front, or you could do 39 to the 1/3 power, whichever way you like that better. So you could go 1/3 log of 39 over log of 4. Either of these can be put into a calculator, but here's the thing. When you have 1/3, you're not supposed to round that to 0.33. They want you to keep it as a fraction. So let's go to our calculator and we can go log of 39 and oops. So log of, and I'm going to do the 39 in parentheses to be, I had too many parentheses here. There was already a parentheses, so I'm going to go 39 parentheses, and then I'm going to put that to the 1/3 power, like that. Okay, division, I guess. Oh my gosh, I'm sorry. Let's try this again. Log, the parenthesis comes, so I go 39 parenthesis, up arrow, and then 1/3. If you guys have an older calculator, you do have to put the 1/3 in parentheses. Then you can enter and then divide by log of 4. Okay, or you could have started the problem with 1/3 and then hit log 39, enter, divided by log of 4. And if interesting. I'm supposed to get this answer. I don't understand why that, oh, okay, no, I did. I understand why those aren't the same. So let's just say this, always bring that power out front, and then you will be okay. I think what it must do is evaluate this and take it to the 1/3 power, and that's why you should have it out front. So let's not keep it like this, always bring that power out front, okay? So we are not going to write it like this. We will only do it like this, sorry about that. And we get 0.8809 for our answer. So always bring the power out front. Okay, so I have a worksheet today. I have the TM here. Really long. Yeah.
Had at least like.
I got you. Yeah. And you guys, I don't know if I've said this before, but Mr. Halsey is really trying to limit. Did I get one for Cody? Really trying to control hallways, which I know has been our theme throughout the whole time. But one of the things he's doing is having secretaries go over all of our sign out sheets. Like, actually, somebody is going through them and looking for kids that are in the hall every hour. And especially if it's every day. So he's asked us to limit, because then what he's gonna do is earmark those kids and then start limiting their bathroom use. Possibly all together. So it's in your best interest not to be gone every hour and not to be gone in a class every day. I have never been somebody who tries to say, no, you can't go to the bathroom, but he's kind of making us do that. So in some of my classes, I'm like saying only once a week. So try that if it's an emergency and you have to go, but I certainly wouldn't be gone every day. So, you know what I'm saying? You don't want to get earmarked.